In our last segment, we talked about markets and how market systems go about answering the three fundamental economics questions of what to produce, how to produce, and for whom to produce. Markets coordinated the economic activity of independent agents, consumers, and producers. Consumers, in effect, direct producers to make goods and services by voting with dollars. Producers who want to make profits choose the methods of production that are most efficient. Firms hire resources, and these resources are paid according to the desirability in production. These payments are earnings, which then determine the distribution of the product. We set up a circular flow model to represent payments from firms to households for resources and from households to firms for goods and services. We also introduced a model of exchange, scarcity, and choice, the production possibilities curve. It highlighted the fact that to get something, we have to give something up. Porsche, you'll have to give up about $48,000. A home is about $480,000, and who knows what a basketball team costs. The essential feature of any market is the price signal. In fact, prices are the coordinating mechanisms that help answer the fundamental economic questions of what, how, and for whom. A price is the amount a product sells for, and it reflects the amount society is willing to pay. In product markets, prices signal scarcity or abundance, and there are prices in resource markets too. The wage rate reflects the rewards for working in different jobs or professions. We can illustrate the role of prices as signaling mechanisms with some examples. For instance, how do consumers tell producers that their tastes or preferences have changed? Let's imagine that people want more beer. As they try to buy more, the price increases. These higher prices signal producers that beer production is becoming more profitable, and firms will want to divert resources to beer production. Additionally, some of the ingredients used in beer will increase in price, for example, hops. As the price of hops rises, wages may increase in that industry. There's been a redistribution of income from people who have to pay more for beer to workers involved in making the ingredients that go into it. So the changes in preferences of consumers can ultimately lead to changes in prices throughout the economy. In this sense, prices are the fundamental signaling mechanism to market participants. Specifically, prices signal producers to increase production when prices are bid up because goods and services are scarce. Prices, in the form of wages, encourage workers to acquire useful skills. Prices give incentives to consumers to use expensive resources carefully, and producers are encouraged to use scarce resources wisely in order to conserve. Since prices are so important, it will be worth spending time on gaining an understanding of just how prices are determined. The model we use is that of supply and demand. Probably the most well-known economic model is the law of supply and demand. In this class, we'll introduce the law of supply and demand and show how it's used. Often, money prices reflect supply. When coffee is plentiful because of favorable weather, it is cheap. But after a crop freeze or a drought, coffee beans are scarce, so the price moves upwards. But supply is only half the story. No matter how rare a commodity, if nobody wanted it, it wouldn't have much value. If a lot of people want something and the supply of it is limited, then that something becomes scarce. In a market system, scarce resources are rationed by exchange. Thus, when demand goes up, prices typically increase. And if people lose interest in something, demand falls. The amount available becomes relatively more plentiful. What will happen to the price? It will fall. When hula hoops were first introduced into the market, the supply was limited relative to the demand. A whole generation of kids wanted hula hoops. They, or their parents, bid up the price. Excess demand means rising prices. Well, what happened over time? Well, with rising prices, the company that introduced the hula hoop was feeling pretty good. Higher prices mean higher revenues, and that means higher profits. With higher profits, the firm expanded production. And what happens when production increases? The supply becomes larger. With a larger supply, the upward pressures on prices are eased. That's the supply side. On the demand side, fads die down. With falling demand, prices tend to drop, so revenues decrease, and so do profits. Although the story seems simple, there's a lot going on that we want to analyze. Let's begin with a model of demand. Quantity demanded refers to the amount of a product that people are willing and able to buy in some period of time at a given market price. How much people want and are able to buy reflects many things which are called the determinants of demand. The most powerful determinant is the market price. Generally, with lower prices, people are more able to buy, so the quantity demanded will go up. The inverse relationship between price and demand is called the law of demand. Demand also is determined by income. If income increases, families are also more inclined to increase their demand. Prices of related goods and services can also significantly affect demand. For example, people's demand for apple juice is influenced by the price of substitute juices, say orange juice. So if the price of orange juice drops, some consumers will switch away from apple juice to the cheaper substitute. As we saw in the hula hoop example, tastes and preferences are also important determinants of demand. And finally, expectations about future economic conditions can influence demand. People who believe gasoline prices might go up in the future might increase their demand for gasoline now. We'll come back and give more examples later. Right now, let's review.
It's time once again for Smart Guy, Dumb Guy.
I don't get it. I mean, I understand about when prices go up, demand goes down. But I mean, what's this about prices of related goods, income, expectations?
Well, when prices go up, the quantity demanded goes down. Okay, that's the law of demand, and it's a movement along the demand curve. See, like this.
Oh, and when prices go down, demand goes up.
Well, no, actually, it's quantity demanded goes up. Look, these economists are picky about the language. When you say demand goes up, that's a shift of the whole curve.
Like?
Like when the price of a substitute changes.
Substitute?
Oh, that's something that you could use in the place of. Okay, if we're talking about demand for cookies, cake would be a substitute. If the price of cake goes up, consumers switch from cake to cookies. So the whole demand for cookies goes up, which is a rightward shift in the curve. See? Look, like this.
I don't like cookies or cake.
No, we're talking about whole markets, not just individuals. Okay, you tell me what happens when the price of a compliment goes up.
Okay. People like milk and cookies, so they're compliments. So when the price of milk goes up, that makes milk more expensive, so people don't buy as much milk. And they also don't buy as many cookies. Hey, so the demand for cookies goes down.
Right.
Right. I thought the demand would shift to the left.
Get a life.
The demand schedule, which is used to derive the demand curve, highlights the important relationship between the quantity demanded and the market price. To generate the demand curve, we isolate changes in market price and hold constant every other determinant of demand. Here's an example. We'll look at the demand for specialty beer in millions of bottles per year. This hypothetical data show that when the price is $3 per bottle, total demand is 1.4 million bottles per year. At $2.50 per bottle, the quantity demanded increases to 2.1 million bottles per year, and so on to the price of 50 cents per bottle when demand is at 8.2 million bottles. Now, a widely used graphical device is the demand curve, which takes this information and plots it in a graph. On the vertical axis, we plot the price, and on the horizontal axis, we plot the quantity demanded. So point A corresponds to $3 per bottle and 1.4 million bottles. Point B shows demand at 2.1 million bottles when the price is $2.50. and so on to point F, where demand at 50 cents is 8.2 million bottles. The effect on the quantity demanded due to a change in price is always shown by a movement along the demand curve. As prices go up, the quantity demanded goes down, and when prices go down, the quantity demanded goes up. It's characteristic for economists to use the phrase change in the quantity demanded to refer to a movement along the demand curve. This is what it looks like. Price up, quantity demanded down, and price down, quantity demanded up. That's the law of demand. There are two important reasons why demand curves have a negative slope. They're called the income effect and the substitution effect. First, when prices go down, people feel better off since they can afford to buy more. It's as if they experienced an increase in their income and can afford to buy more. That's called the income effect. The substitution effect means that people move away from relatively more expensive goods to cheaper ones. So when the price of pasta falls, this food becomes relatively more attractive than it was before, and the quantity demanded for it goes up. Now, what about the other determinants of demand, such as income or tastes and preferences? Let's go back to our pasta example. Remember that when we derived the demand curve, we held constant every other determinant. That's called the ceteris paribus assumption. It's just a matter of convenience to do our analysis and focus on price changes only. Now, when we relax this assumption, we can also explore what happens to demand. Recall that the prices of related goods and services are important determinants of demand. For example, let's say that the price of spaghetti sauce decreases. Pasta and spaghetti sauce are called complementary goods. People use these products together. And when the price of a complement goes down, that causes the demand for the primary product, spaghetti, to go up. And that's seen as a shift to the right of the demand curve for pasta. Here's the way it looks. When we talked about a movement along the demand curve, we said there was a change in the quantity demanded. And when we talk about a shift of the demand curve, we say there's a change in demand. So here's our demand for pasta. When the price of sauce goes up, that reduces the demand for pasta. The effect when the price of a substitute changes works in the opposite direction. Let's say that Chinese noodles are a substitute for pasta. When the price of noodles goes down, people switch from pasta to noodles. What will happen is that the demand for pasta will go down, which is seen as a shift to the left of the demand curve for pasta. So when the price of a complement goes down, the demand for the primary good goes up. And when the price of a substitute goes down, the demand for the primary good goes down as well. It works just the opposite for price increases. When the price of complements go up, demand for the primary commodity falls. When the sauce price increases, the demand for pasta will decrease and the demand curve will shift to the left. And when the price of a substitute for pasta goes up, that increases the demand for pasta as consumers switch away from the relatively more expensive food. Another important determinant is income or accumulated income, which is called wealth. A family's income is the aggregate of all its earnings, including wages, rents, interest payments, dividends, and transfer payments from the government. When households have more money to spend on commodities, the demand increases, which is seen as a rightward shift in the demand curve. Here's the way we see it. The graph shows a demand curve for a normal good, such as travel. When my income goes up, the demand shifts to the right.
But we do have one wrinkle. There are some types of products called inferior goods where this doesn't hold true. Otherwise, for normal goods, there is a direct or positive relationship between income and demand. With inferior goods, when income goes up, demand goes down. Goods such as cafeteria food, used cars, bus transportation, or repair services are examples of inferior goods. Remember, though, the term inferior refers to the relationship between demand and income, and not to the quality or desirability of the product. It just refers to the empirical relationship between changes in income and demand.
In areas such as fashion, music, and style, consumer tastes and preferences are volatile, so demand changes rapidly. In recent years, people have become much more health conscious. The demand for healthier foods has increased significantly, while the demand for cigarettes and high-fat foods has dropped. We see these shifts in the demand curves for these products. Now that we've talked about demand, it's time to talk about supply. The discussion is somewhat parallel. We begin by discussing the relationship between price and the quantity supplied, and then we talk about other determinants of supply. Supply refers to the quantity of a good or service that a producer is willing and able to offer for sale at a given price or a given time period. Unlike with demand, supply is positively related to price. This relationship is called the law of supply. There are several reasons behind this law. First, prices reflect market incentives. With increasing prices, producers who are seeking profits have incentives to devote time and resources to additional production. Existing firms have incentives to expand, and new firms may be enticed into the industry. This reasoning applies to all markets. If babysitters are difficult to find, parents respond by offering more money. That encourages kids to devote more of their time to babysitting, an increase in the supply. Well, it works in traditional markets too. If businesses are having a hard time finding workers, wages go up to induce people to give up leisure for labor. Another important explanation as to why there is a direct relationship between supply and price refers to the production possibilities curve. Let's review this graph and talk about opportunity cost. On the vertical axis, we'll plot soybeans, and on the horizontal axis, chicken. The curve shows us how much of each commodity could be produced given all available inputs. Recall that the slope of the curve is related to the opportunity cost of the commodity plotted on the horizontal axis. As the supply of chicken increases, more and more soybeans are given up. So the cost, or the price of chicken, exhibits a direct relationship to the supply of chicken. Well, let's look at some hypothetical beer data. We see that when the price is $3 per bottle, total supply is 8.4 million bottles per year. At $2.50 per bottle, the quantity supplied decreases to 6.1 million bottles per year, and so on to the price of 50 cents per bottle when supply is 1.2 million bottles. When we talked about demand, we noticed that there were other determinants that shifted the curve. This holds true for supply as well. The big shifters of the supply curve include technology, prices of inputs, prices of other goods, and expectations. When technology advances, that leads to a shift in the supply curve. And when factor input prices change, that shifts the curve as well. For example, when the price of raw materials goes up, firms are less able to produce at the old price, so the supply curve shifts to the left. Producer expectations about future economic conditions also shifts the curve. If firms anticipate new technology that will be available in 2 years, managers may postpone current investment, which leads to a leftward shift in the supply curve. Well, now that we have the model of supply and demand, we're ready to model how prices are determined. Well, that's coming up in the next segment, so stay tuned.
In Utah, as in many western states, water is a very precious resource, and consumers are urged to conserve it and use it wisely. Now, if prices are a measure of scarcity, we'd expect the price of water to be high. Yet the price of water is very low, which tends to work against conservation efforts. So we have a bit of a paradox, a precious commodity with a low price. And how to account for this tension is related to the fact that people believe water is a necessity and that there are no substitutes for it. And because it's a necessity, water prices must be low. But in fact, there are many substitutes for water, but they are underutilized because of low water prices. For example, a substitute for a leaky faucet is a plumbing repair. Bricks in the toilet or fewer flushes replace water. Using an ice cube to cool a drink rather than letting the water run cool uses less water. Brown lawns or dirt putting greens, dirty automobiles are also substitutes for water. So in the face of a drought, how can these substitutes be better utilized? Well, commonly, governments impose fines or regulations or initiate public service advertisements to encourage people to conserve. But there's a different approach that may be more efficient and not require intervention and enforcement.
The economic solution is to increase the price of water. Almost certainly, dirty automobiles, brown lawns, and plumbing repairs would replace water if the price of water went up. With high water prices, consumers can quickly discover substitutes. We know that consumers and producers adjust behavior according to price. In this episode, we put together our model of consumer behavior, the demand curve, along with our model of producer behavior, the supply curve. What comes out is our model of price determination. In this program, we'll discuss 1, what an equilibrium price is, and 2, how prices change in response to changing economic conditions. But before we go on, let's review the demand curve and the supply curve.
And now it's time for Chalk Talk with your host, Miss Sarah.
Okay, we're going to derive a demand curve. We've got this information that tells us, for example, when the price is $3, quantity demanded is 1.4. When the price is $2.50, quantity demanded is 2.1, which makes sense. As the price goes down, the quantity demanded increases. So what we're going to do now is we're going to draw this information graphically. We always put quantity on the horizontal axis and price on the vertical axis. So now what we'll do is we'll just plot a few points. When the price is $3, quantity demanded is 1.4. So there is 1 point on our demand curve. When the price is $2.50, quantity demanded is 2.1. So there's another point on our demand curve. If we do one more, say when the price is $1, quantity demanded is 5.8. Price is $1, 5.8, right there. If we were to plot all these points, we would come up with a demand curve that looks like this. A demand curve is always downward sloping because as price falls, quantity demanded increases.
We see that when the price is $3 per bottle, total supply is 8.4 million bottles per year. At $2.50 per bottle, the quantity supply decreases to 6.1 million bottles per year, and so on to the price of 50 cents per bottle when supply is 1.2 million bottles. When we talked about demand, we noticed that there were other determinants that shifted the curve. This holds true for supply as well. The big shifters of the supply curve include technology, prices of inputs, prices of other goods, and expectations. It's no accident that we've described demand and supply in a symmetrical way. The dimensions are identical. Prices are plotted on the vertical axis and quantities are plotted on the horizontal axis. When we put the two concepts together, we can understand how prices come to be what they are. The equilibrium price matches the quantity demanded with the quantity supplied. When the price is below equilibrium, demand exceeds supply, and when the price is above equilibrium, supply is greater than demand. Equilibrium means there's no tendency for change. Economic forces tend to push price toward equilibrium, just as gravity tends to pull matter to a center of mass. In a market, if the price is at equilibrium and there are no outside forces, there are no pressures for prices to increase or to decrease. What's amazing is that in a free market, the institution of the market determines the equilibrium price. Upward pressures on price reflect shortages or excess demand. Retailers find inventories declining, and by increasing price, available supply is rationed. With excess inventory, there's a downward pressure on price. Products go on sale to equilibrate demand and supply. Of course, our model is temporal, so in reality, prices are always in flux since demand and supply are not static. Nonetheless, it's useful to abstract away from time in order to understand what happens in a dynamic world when things too get fuzzy. The data in the following table is an example of what we mean. At each price, we show the quantity demanded and the quantity supplied from our previous examples. In looking at the data, we see that when the price is $3, supply exceeds demand, and at $1, for example, demand exceeds supply. This market is in equilibrium when demand equals supply at $1.50. When we plot the demand and supply curves, we see their intersection represents equilibrium. In the graph, we see the familiar downward sloping demand curve and the upward sloping supply curve. At prices above $1.50, supply is greater than demand, and below $1.50, demand is greater than supply. With this model, we were able to show how prices change when market conditions change. So now let's introduce time and see how there's a tendency to move from an initial equilibrium price to a new equilibrium price. For example, when producers face bad weather, the supply curve shifts to the left. At existing market prices, demand exceeds available supply. This supply needs to be rationed, so there's an upward pressure on prices, which is the rationing mechanism. Well, let's see what this looks like. We begin in equilibrium at P0 and Q0, which corresponds to the intersection of demand curve 0 and supply curve 0. With bad weather, the supply curve shifts to the left to S1. At the old price, P0, demand exceeds supply, so there's an upward pressure on price. As prices increase, there is a movement along the demand curve. As the price goes up, fewer people are willing or able to purchase. The lower available quantity is distributed to those who are willing to pay higher prices. This process continues until we reach the new equilibrium price, P1, and quantity, Q1. Another application of the model is to analyze the effect of a tax on a commodity. A simple example is a per unit tax. The effect is to shift the supply curve upward by exactly the amount of the tax. Here's an illustration. We begin again at SO and DO with pre-tax equilibrium price at PO. Let's impose a $2 per unit tax, which shifts the supply curve vertically by $2. The new equilibrium price is at P1 and quantity at Q1. Notice that the price went up, but not by $2, which was the amount of the tax. That's because the movement along the demand curve, which decreased the amount consumers were willing and able to buy. For example, with the tax, some consumers decided it might be better to switch to substitutes.
Using the model of supply and demand, we can predict directions of change, but so far we can't predict the magnitudes. If price goes up by 10%, we know the quantity demanded will fall, but by how much? When the price of Chardonnay goes up, people will switch to Fumé Blanc, but by how much? With this in mind, in our next episode, we'll look at the nature of economic quantification. So take a break and we'll see you next time.